Hi Year 11, it's Mr. Wilson here. I'm going to show you today how to distinguish between some more metal ions. And this time we're going to do it using flame tests. Now the way a flame test works is that we're going to put the metal ions in somewhere hot. What happens when you add a load of thermal energy to the ions is that the electrons can slowly move up through the energy levels. So we're putting thermal energy in. This moves the electrons up and up and up through the energy levels in the atom until eventually they get to a certain point. And sometimes there's a really good pathway to go from one energy level all the way down to the bottom. Like the energy levels are connected by what we call different symmetries and different angular momentums. So when you get to the right point, the electron can suddenly jump all the way back down to its original energy level, having slowly gone up. Now it slowly goes up by gradually absorbing energy. When it drops all in one go, it gives out a big chunk of energy. So it gives out a high energy photon. And that photon, for many metals, is in the visible spectrum. So what that means is that when I heat these metal ions and energize the electrons, and then they drop back down to their initial energy level and give out a photon with a visible wavelength, we see pretty colours. I'm going to turn the lights off and I'm going to take you through 5 metals. Okay, let's get some blue flame going on the Bunsen. It'll be a bit dark for you now. I'm starting off with a copper salt. So these are copper ions. I'm going to take the copper ions, put some on a damp splint, put them in the flame. And with copper, the colour that we see is green. Bit of Avada Kedavra, Harry Potter going on. So copper produces a green flame. That's the wavelength of the photon that's emitted. Remember, all the different metals are going to emit slightly different wavelengths because of their slightly different electronic structures. This time I'm going to do potassium. So we saw copper was green. We're going to see potassium is... Oh, that's not right. Potassium should be purple. There's a little bit of purple in there, but there's a bit of orange, which tells me that what says potassium chloride in the salt, on the side, there's a little bit of purple there. I'll try it one more time, but I think my potassium chloride has been contaminated with some lithium or some calcium. Let's get plenty of it on here. Let's give it another go. Yeah, that's definitely not potassium. That could be strontium, it could be lithium, it could be calcium, but that's not potassium. So you'll have to trust me on this one. The potassium, I'm just going to clean some of the residue off the top of the Bunsen. Potassium should be purple. So we've got copper is green, potassium is purple. This time I'm going to do sodium. Sodium is going to be a nice bright, moment of truth, I don't want to tell you too early, yellow. There we go, there's the sodium. Sodium is like a yellowy orange. That one works a lot better than potassium. So we're 2 out of 3 have worked so far then. Let's try some lithium. So we have potassium purple, copper green, sodium yellowy orange. Lithium is red. Definitely red for lithium. Although again, you can see some red, but it does look like there's a bit of sodium in there as well, or something else contaminating it. You can see all the mix of colours. These, oh wow, there's some red lithium. That's much better. That's the red lithium we're looking for. That was lithium is red. And let's clean the top of that off again, because again, I've got some residue falling off the sticks onto there. Lots of colours coming through from my residue. The last one that I will do is calcium. So we've had potassium purple, copper green, sodium yellowy orange, lithium red, finally calcium. Oh, this is real damp and congealed in here. I'm concerned that this isn't going to be very pure either. Let's get plenty onto the splint. Calcium is an orangey colour as well. So it's more like an orangey red as opposed to sodium that's orangey yellow. There's calcium, it's a orangey red. I'm going to turn the lights back on and we're going to look at another piece of kit. Let's get the safety flame. There you go, now I feel much safer. so what I've got here is a flame tester, or it's an emission spectrometer. So this is going to produce a spectrum. You can see I'm aiming it at the Bunsen flame. The light travels in here, and there's a diffraction grating in here that's going to separate the light into different colours. Different wavelengths will be diffracted differently by the grating, so we can see the different colours of the light. So if you're doing a test, you need one of these because every single metal ion, we said, emits different wavelengths, which means slightly different colours. But because they're specific, if we separate out the colours, we can really clearly see. So what I'm going to do now, I'm going to put the camera right up to the spectrometer, or spectroscope you could call it. There we go. So you can see through there. Look at this. Wonders of technology. I'm actually just going to turn this because I had a slightly better picture before. Let's go. I reckon that's the best we're going to get. So we can see the rainbow at the moment because all we've got is the broadband light from the hot flame. I'm going to turn the lights off again, go to blue flame, and then put the different metal ions in there, and we'll look at some of the spectra. I think I'll probably just do the copper and the sodium because they were the purest ones I had. Okay, so you're now looking through a camera, through a spectroscope. Here's my blue flame again. Again, I need to just tidy this up a bit because I don't want any impurities around my flame giving me the wrong colours. There we go, look at that. That's better. I'm going to get my copper chloride. Now we're going to see a nice bright green colour in the flame. I want you to see what it does to that spectrum that you're looking at, all the different wavelengths of light. So I'm putting the copper salt into the flame just about now. Okay, I'm going to do that one more time. I want you to see what it does to the spectrum of light colours that you can see. So when I put the copper in, we get real bright green and red lines. There's no blue in that rainbow. So that's telling us the specific wavelengths that are present, which we can use to work out exactly what metal ions there are. Now, if you have this is a very simple diffraction grating to create this. You could also do this with an instrument that could identify the spectrum for you by looking at exactly what lines there are, and also can look at the intensity of light. Can look at the intensity of light. So you could do flame tests with solutions, and then by looking at the intensity of the light, you can work out the concentration of the solution. So these spectroscopes or spectrometers are very useful for working out not just what you've got, but also how much of it you've got. And that's all we got for today. Thank you for watching.